Bessma Momani. I'm professor in the Department of Political Science and Assistant Vice President of Research International at the University of Waterloo. I'm really happy to be moderating this wonderful panel with you today. Before I go into introducing our wonderful panelists, I'd like to just first give you a little bit about who we are and kind of why we're doing this, if I may. So artificial intelligence and warfare is something that I think, for lack of a better term, has become seen as inevitable in some circles. But I think we come to this webinar as academics and as interested members of the Artificial Intelligence Institute, really kind of concerned with where this technology is going. What are the limitations? What are the ethical issues? What are the legal issues? There's so much, focus on the fairness aspect of it with algorithmic biases. Certainly the transparency of this technology, the governance of this technology, is it going to be regulated? All of these great questions are things that we want to address in the series of 6 to 8 different webinars that we'll be having in the next several months. And the goal is by the end of December, we would have had, again, 6 to 8 webinars. We're still finalizing some details. So please stay tuned. We do have this all featured on the Artificial Intelligence website. And the goal is to continue this wonderful opportunity to speak to experts from a variety of backgrounds. And we're really keen on bringing in both technical people and policy people, or industry people and governance people. And the idea here is that through this interdisciplinarity, I hope we get closer to being better informed. We take no position on whether or not it should be used, but more likely, we think it might be happening at some point, and we need to be better informed. So I hope we all see that this is really not an endorsement of the technology as much in its application, as much as trying to provide all of you folks the real issues that need to be discussed, and I think to be a really informed audience. I also want to mention that today's webinar is co-hosted by a number of great folks. Of course, Artificial Intelligence Institute at the University of Waterloo is our main host. But we also have some partners today that I'd like to just introduce to you. We have the Defense and Security Foresight Group, which I'm the director of. This is a network of academics across Canada interested in defense and security from a variety of, again, perspectives, and really questioning it. Questioning sort of, how we move forward in the space of defense and security in this country. We also have NADSDN, which is the North American and Arctic Defense and Security Network, one of our parallel groups that is also looking at the issues of Arctic governance and writ large, a lot of great issues. I encourage you to all look at their website. We'll have my colleague Kirsty try to do that in the chat if possible. So we're here to, as I said, to really give you this rounded perspective if we can. We're very open to your questions, and we're going to stay, obviously, we have an hour and a half. The last half hour will be open to you folks to ask the questions from these experts. But do keep in mind, we have many different types of panels being organized in the hopes of getting at this thorny question. So there's more to come. Lastly, one of the outcomes of this panel series, particularly the next one and beyond, is going to be a digital essay series that CG, the Center for International Governance Innovation, which is very much now at the cutting edge of trying to understand this interplay of digital technology and governance, and even on some cases, ethics, legal, global governance. And so we're really very proud of this relationship that we have with CG, where I'm also a senior fellow, and Maura as well. And the idea here is that we hope to have, again, a sort of a permanent copy, if you will, a digital essay series that can be, I think, further used for all of you folks to sort of broaden your understanding of this really important issue. Okay, without further ado, I'm going to introduce our panelists. So Dr. Maura Grossman is a research professor in the School of Computer Science at the University of Waterloo, adjunct professor at Osgoode Law, and an affiliate faculty member at the Vector Institute, all in Ontario, Canada, as well as an e-discovery attorney and consultant in Buffalo, New York. She was counsel at a number of very important legal organizations representing some Fortune 100 companies. And Maura is really well known and influential in her work on the issue of, I love the title of this, Maura, by the way, who's who litigation e-discovery analysis as a sensational, according to her peers, and go-to in the area on technology assisted, on oh my goodness, on technology assistance review. She's published widely in the Law and Technology Journal and other great peer-reviewed publications. So lots to say, of course, Maura, but we're trying to be as succinct as possible, and you have such an illustrious career, so apologies for shortening this. Then we'll turn to Matthew Kellett, who comes from the Department of National Defense. Dr. Kellett joined the Department of National Defense in 2002, spent 15 years as with the Defense and Research Development Canada, first as a scientific support and then as a defense scientist, also researching the security of military wireless networks, intelligence support to cyber operations, and cybersecurity metrics. We'll turn then to Robert Engen, who is at the Canadian Forces College. Dr. Engen holds a BA from the University of Calgary, MA and PhD in history. I love this, from Queen's University, and has held SSHRC postdoctoral fellowship from RMC Canada, and has worked as a project historian for the Battle of Hill 70 Memorial Project, and is co-director of the Second World War Research Group North America branch. Lots to say as well. So welcome all of you. Again, you'll please have a chance to look at our webpage to see the bios of all these great panelists. So let's begin. Let's get into the meat, if you will. I'm going to turn to you, Maura, first, if I may. I think one of the goals of this was to also provide a webinar series that someone like me, who's absolutely not a techie in any way, has a very basic understanding of what AI is, machine learning, all these other great new emerging technologies may be, but knows that there's something going to happen out there in its application. And if you're interested in defense and security and militarization, and one can be also a critic of that, know that this technology is going to be really useful. So, but before we go there, would love for you to just help us sort of define artificial intelligence for us, and how it's used perhaps in your work, and again, what sort of a layman person needs to know about artificial intelligence.
Sure, thank you very much for having me, and I'm going to give you the 5 to 7 minute AI 101 version of courses at Waterloo that are entire semester. So artificial intelligence is an umbrella term that was first used at Dartmouth in 1956 at a summer conference. And basically what it meant was computers doing intelligent things, performing cognitive tasks that were once thought to be the sole province of humans. So thinking, reasoning, and so forth. It's not a single technology or function. And basically, often colloquially, we say it's whatever a computer can't do until it can. And then once we get used to it, we call it software. So there are many things like spam filters that we thought were AI when they first came out. And once we get used to them, we just call them software. And it is different from automation and robotics, even though people smush these terms together. So automation is simply replacing something that was done by a human with a machine. So if you think about it, your dishwasher or your washing machine are automation, but they're not necessarily AI. And robotics, again, is more on the hardware end. It's the technology that operates and acts in the world. Again, it may or may not have AI. When a surgeon does robotic surgery, there isn't necessarily AI in that. So we have to separate these terms. And I think that is going to be an issue in some of what we talk about today, because there are tools of war that are automated that are not necessarily AI, and vice versa. Generally, there are two types of AI. One is called narrow or weak AI, which is where AI is doing one task as well as or better than a human. So it might be playing chess or Go or reading radiology plates. And then there's general or strong AI, where the AI is thought to be as good, if not better, than a human at all of the tasks. And there is debate in the community about whether we will ever have general or strong AI, but we already have narrow or weak AI today. So in the past, if you wanted to program a computer to do something, you would have to sit down and come up with every single step that you wanted to program the computer to do. So I remember when I took my first programming course, and it was basically me and a bunch of 6-year-olds, and I was the least skilled in the class. But we had to come up with a point of sale system. In other words, like an Amazon tool where things go into the basket, and then you add the tax and take off the coupon and so forth. That's actually programming where you have to come up with every single step in the correct order and then sort of translate it into another language. Today, we don't have to do that. We don't have to construct the rules. We can give a system data and it will construct the rules by itself. And that's typically what we are talking about when we're talking about machine learning. So there's unsupervised machine learning where the system looks for naturally occurring patterns or clusters or groups or anomalies. And then we have supervised machine learning. So if I want to teach a computer the difference between a cat and a dog, I don't have to list all of the characteristics of cats or dogs. I can give the algorithm pictures of dogs and cats, and it will figure out what are the characteristics that distinguish a cat and a dog without my ever telling it those. And then I can give it an unlabeled picture, and it will figure out whether it is more dog-like or cat-like. And then finally, there's reinforcement learning, where the system learns sort of by trial and error. It tries out different solutions, and it gets reinforcement when it is optimizing whatever goal you are trying to optimize. So there are many types. They have pros and cons, which we'll talk about. Some of them are seeking simply to look for patterns or probabilities. Others are trying to actually generate meaning. That's generally called natural language processing. But that's AI in 101. And in terms of what kind of problems AI can solve, it can classify or predict something. It can rank something, so it can classify or predict dog or cat. It can rank from most dog-like to least dog-like. It can do something called regression, which is to put a numerical estimate of the probability of dog or cat. And then, of course, there's conversing or translating, things like chatbots, where it actually tries to understand and converse back.
Thank you, Maura. I know we have lots of questions on this, and we'll come back to you about it. I want to turn to Matthew. Matthew, could you just bust some myths for us here? Like, you know, how and where is artificial intelligence being used by the military? But more importantly, where is it not being used, but people think it is, if you will? You know, I mean, I always think of pop culture and killer robots and all these, you know, really interesting kinds of you know, mythologies, if you will. So can you break it down for us in terms of what it is, where it is being used, where it's not being used, but more importantly, where people think it's being used, but you can clarify where we are with that?
Sure, I'll see if I can come close to that. First, I should probably situate myself within the Canadian Armed Forces and the Department of National Defense. So I'm a civilian, I'm not military. And after my 15-year career at DRDC, I moved to be a special advisor to the Joint Force Cyber Component Commander. So standing up of a new domain of warfare, cyberspace, and I'm the technical backstop for the DG to help him understand the space and the challenges within it. And so my view is very much of cyber, and I can probably safely say that we're not using AI in any significant way yet in the cyber realm, but it is one of those places where the narrow or weak versions of AI that Maura described would be extremely applicable. And I know that DRDC, and people can go and talk to DRDC about this, but I know DRDC has chosen this as one of its areas that it will look at, because this space has just exploded in the last 5-6 years, and the hype that has gone with it. Every vendor has come out and said, we are using AI, and as Maura said, no, sometimes it's just software. And so I generally look at things like neural networks as being, the thing that is most AI. A computer that's designed to try and think like a human using fake neurons. And that is where we've gotten a lot of advances in artificial intelligence, in pattern recognition and classifying, and being able to recognize birds, and doing Google reverse image search, and it being able to tell you, being able to search for sunrise on a beach and getting lots of pictures of sunrises on beaches. Problem with that is that, if anybody's ever used Google Translate, it's not exact. And the risk tolerance in the military and the legal requirement to, when we're using things like lethal force, are so high that we can't have good enough. We have to have, it has to be extremely accurate, and we have to know the risks that are involved. So, do we have killer robots ready to go out on the field? Everybody's seen the Boston Dynamics videos that have been on viral media of them dancing and doing somersaults, and they're not going to have human brains, and probably nobody smart will hand them a gun anytime soon. I am unaware of any of the services working on anything that would be deployable. That doesn't mean that they aren't looking at artificial intelligence, because it has the ability to solve a whole bunch of problems. Or I like to make the distinction between decision making and decision support. So AI is excellent for decision support, telling you what it thinks something is and letting a human decide, which in a military context is often the way that you want to go. When you hand that thing autonomy, so when you hand it decision-making power, then you run into a whole level of risk and legal liability that you have to address. So yeah, all that to say that I don't think we're using killer robots. We have no intention to. That doesn't mean, like, there aren't somebody who may go find that some piece of software we're using has like a neural network doing part of its job. That's quite possible, but it'll be because that part of its job is not a risk to anything, not a risk to a mission or to human life. And so, it's possible we're using AI, but it's not, we're not, developing killer robots, for instance.
Thanks, Matthew. That really, really helps. Robert, I'm going to turn to you. I want you to give us sort of the state of the art, and where are we in this? I mean, you as a military historian, I'm sure you're watching the evolution of this, but also I'd love for you to give us, and I know historians hate to be asked, where do you think it's going? They don't like to predict the future. That's where they come to the political scientists. But where do you think we are? How do we got there? And where are we going to go? If I be blunt.
Sure, absolutely. I'll situate myself as well. I am a historian by training. My current employer is the Department of Defense Studies at Canadian Forces College, which is our senior staff college. So like Matthew, I am a civilian employee of the Department of National Defense. At the college, I've taken over most of the teaching of artificial intelligence and machine learning topics, both for our senior and our junior courses, in part because I'm fairly current on the literature. I don't come at it as a practitioner, I come at it as a historian. And so I take if it is possible to take a long view of artificial intelligence, I try to do so. This field has, and I'll start off by saying it's difficult to discuss the state of the art in this field because it's something of a moving target. And as both Maura and Matthew have already discussed, I think we're actually going to, our views on this are probably going to be quite closely aligned. There are, the problem with artificial intelligence is that it is, it's not just one thing. It has the potential to be what could be referred to as a general purpose technology, something like the steam engine or electricity or even computers, something that has the potential to remake many different fields of endeavor, from all of its consequences and first and second order consequences. Think about how the steam engine or electricity changed the world and allowed for industrialization and so forth. We don't know exactly be where AI and machine learning are ultimately going to lead, because we're continually finding new ways that we can apply ideas of classification and the ranking and regression analysis to the to different fields. And we're finding that there are more and more tasks out there that we thought would require generalized human intelligence that, in fact, you can actually accomplish quite handily with this narrow artificial intelligence that we have. And so we haven't found the borders yet of what the possible is going to be. But to elaborate on that a little bit, I think that this field has fairly recently reached a threshold of feasibility and efficiency that has found a profitable return on investments. Whereas in the 50s, the 60s, the 70s, the 80s, the artificial intelligence was something of a black hole of fundamental research into which grant money vanishes without a trace. Which is, I think, is kind of a good description of the field's natural resting state. It's only been about since 2010 or so that the AI field has experienced the really great breakthroughs in its 70-year history. And major commercial interests are monetizing those new capabilities on a very wide scale. So historically, the field of AI has seen cyclical phases of excitement and promise, followed by crushing disappointment and the reallocation of resources away from that field. I know that DRDC, who Matthew has worked with, did a lot of work with neural networks in the late 1980s, the exact same sorts of things that ultimately led to deep learning and many of the advances. But at that time, it was something of a dead end, and it was largely seen as well, this might be an interesting road to go down, but it's not going to lead us to general artificial intelligence. And the breakthrough on that technology required another 20 or so years to actually reach fruition. So the cycle of crushing disappointment and then excitement and crushing disappointment has probably ended now that AI is delivering results and achieving high levels of profitability and utility. But that said, so far, no AI system can compete with my 3-year-old daughter for generalizable intelligence. No AI system to date possesses a shred of understanding and a human sense of what it is doing. Despite endless attempts to anthropomorphize them, computers are mathematical processes for symbol manipulation. Sometimes they're executed well, sometimes they're executed badly. And AI systems do not know what the world is. They don't know what humans are. They don't know what words mean. They don't know what its goals are. They don't know what goals are, period, full stop. They follow strings of coded binary operating instructions, and they can play a perfect game of chess in a room that is on fire. So, I mean, which is kind of a long way of saying that there are real limitations. I think this is going to feed into the next question that is going to be put back to Maura. I'm very interested to hear her answers on this. That there are we don't know exactly what the full scope of what can be replaced and what AI is going to be able to do. We do know that we're a long, long way from any kind of generalizable intelligence of machine learning that could really switch between tasks and can apply learning from one field to another or learn from a very small number of examples. What we have is tremendously useful and tremendously profitable, but that comes with a lot of caveats attached to it.
Yeah, thanks, Robert. And you know what I like is that you also kind of demystified this with that 3-year-old example. And I'll just, put out there, Heather Roths, who's well known in this community, is a good friend of mine. And she once said this great line that I'll never forget, which is, like your Roomba is artificial intelligence, right? Like we can over romanticize it or, make it bigger than it is. And we see killer robots, that general dynamic, is absolutely, I think, the sort of quintessential view some of us think we're going towards, but it's not there yet. And more importantly, it is everywhere too, right? In so many ways. That doesn't suggest that there aren't inherent challenges and biases, because that's really scary and that's what we want to prevent. So yes, throwing the question to you, Maura, would love for you to talk about these limitations. So for one example, if I may point out, we keep hearing about this, all about data, right? And we talk about, for example, in the global race for AI, which I know we're going to have a panel on, but I'm fascinated with as an international affairs person, how, for example, China, with access to so much data by virtue of its population, by virtue of its complexity of a society, has so much, data points and what may end up being a leader in this space because of it. So yeah, I'd love for you to talk about what are these limitations, also if you could reflect on our capability. I mean, I'm really curious. We at the University of Waterloo also, certainly see ourselves as one of the world leaders in many ways in the space, but, maybe we're an aberration here, outside of really great technical universities. We're not seeing the same kind of widespread use or understanding of this technology. So yeah, give us a sense of what are the limitations and where it is, if you will.
Okay, so some of these have more to do with the military context than we're talking about, and some of them less, but I'll go through some of them. So one challenge can be difficulty with nuanced determinations. So is this a child with an ice cream cone, or is this a child holding a toy gun, or is this a child holding a real gun? Is this a person who is really injured, or somebody who is faking injury and will attack? And those nuances that can't always be made go to, for example, distinction and proportionality in international law. Can these tools make sufficient distinctions to know a civilian from a combatant? Can they decide whether this use of force under this set of circumstances is proportionate? Lack of transparency and explainability. I know there is a movement called XAI, or Explainable AI. DARPA in the US has been a leader in that area, but if the commander doesn't know how it works and can't explain the functioning of the weapon, is that appropriate to be using it? You've mentioned bias. Many of the machine learning tools are trained on past data to make a prediction about a future situation. And so, for example, if you look at some of the problems that facial recognition systems have had in dealing with women of color. So now you mentioned China. Well, what if all the data is trained on pictures of Chinese people? Will it be able to make proper distinctions on people of other races? Another issue is ethics really can't be well codified. It's very contextual, it's very cultural. So how do we build that into these tools? There's an accountability gap, because most of the rules and regulations, for example, the recent draft in the EU, the Canadian directive, have exemptions for national security, for military uses, so you don't have good controls. And one that bothers me the most, or a lot in this particular area, is in many situations, we can compare AI system to a baseline. What are we doing now, today? Is this actually an improvement? It is very difficult in the situation of military use to, well, let's have one war where we use the AI, and we'll have another war where we don't use the AI, and we'll compare the number of people, civilians who were killed. We can't do that. So you see a lot of the arguments about these tools are made, they're subjective, they're made from an emotional standpoint without the benefit of the empirical research that we can do in other areas of AI. And that troubles me a little bit. We actually don't know whether these tools are better or worse than a human would do in that situation. And of course, another issue in the military situation is the distance from the person who may be using the AI to the actual use of the AI, and it becomes more of a video game than a killing of a real person. So there are a number of issues, some of which relate more to the military application, and others that apply more generally to all of AI.
Yeah, thanks, Maura. I mean, that example that you talked about, which are really drones, right? I mean, this idea of sending out drones And that separation of the pilot from the place of target, we know that actually that separation, if you will, kind of diminishes the sense of responsibility, right? I mean, we know this. This is, psychologists have shown this, that, you're more likely to be a little haphazard in your targeting if you're a pilot, a military pilot, when you're behind, a computer screen, than if you are literally above the sky or you're seeing what you're hitting. And so that's fundamental, right? I mean, I think for those of us who clearly, do not want to see, not just, I hate the word collateral damage because that's not, fair, but, the killing of innocent people, right? That's at the end of the day what we're trying to avoid. How to do that, I think, is really important.
Counter argument, Bessma, is if you're standing there, your tendency is shoot first, ask questions later. If you're thousands of miles away, perhaps the instinct can be, well, I'm far away, I'm not at personal risk, maybe I can take that few more minutes before I make a decision. But again, going back to the empirical issue, we can't do that study, so we don't know. Yeah. We don't really know the answer. So there are arguments and counter arguments for all of this.
Yeah, and to add to your counter argument, I've also heard that there are more checks and balances because you actually have, the chain of command sometimes in the room with you, if you will. So there's multiple layers of check. So I've heard that argument as well. But this is a thing, right? We're really just starting to get into some of these really thorny ethical issues that I think we're going to have to come around. And one last thing I just want to point out, I was at a presentation where someone was talking about sort of gender in AI. And she put out this example that if you Google pilot, you'll have to go through pages and pages and pages of seeing, a woman or a person of color. So like that kind of sort of, which clearly suggests, if you're recruiting, if you're not just in the military space, but, civilian pilots as well, little girls are not going to see themselves as pilot if for God's sakes, the internet can't see us as pilots, right? This is really, really important about, a wider conversation of biases. So thank you for raising that. Let me turn back to you again, Matthew. So, what has been the role of the military in the development of AI? You talked about DRDC, which, is, and I'd love for you just kind of, if you don't mind, give a quick kind of 101 on what DRDC is, because some people may not know what it actually does. And so, where has the Canadian military been in the development of AI? Or if you can add perhaps even not just the Canadian example, just sort of globally, because, I think we can all be honest and say that, Canada's capability is not going to be the same as the Americans and others. So if you can give us a little bit of reflections on that, I'd really appreciate it.
Sure. DRDC is the civilian agency that does research on behalf of the Department of National Defense, and it also has an arm that does supports it's called the Center for Security Sciences. It supports public safety. And the idea is that it's an applied research center that looks across all aspects of defense and security and looks at Horizon 3, so 10 to 15 years out, like not exclusively, but they're looking for what's coming. And artificial intelligence is one of those things that they're looking at. Quantum computing is another obvious one of something that they're looking and what's coming. What happens when you get much closer, as we would say, closest alligator to the boat, as you get closer to the boat, AI becomes less theoretical and much more practical. And then you can actually measure whether it's a good application or not and how much risk it has. And so, as I said, I'm not aware, I'm off in a little cyber bubble, so I'm not aware of what the services are doing with AI. I'm absolutely certain that the US is pushing in this space because this is one of those spaces where they would absolutely want to maintain superiority. And that's one of the ways that they use their military is to ensure superiority in whatever battle space that they're entering. And so they will be looking at all these things. And I think of like DARPA grand challenges, like getting a truck to drive across the desert for 1,000 kilometers, 1,000 miles or whatever, autonomously. That sort of thing is sort of an AI application. It's DARPA, so the Defense Advanced Research Projects Agency in the US. So it has military applications. especially for like resupply convoys, and why put people at risk of roadside bombs if you don't have to. So I can see I see obvious examples of that, but as for like specific examples, I'm still seeing things more as a research thing. I do want to address what one of the things that or sort of add emphasis to some of the things that Moira was saying, specifically about the legal and aspects of using AI for the military. In that, under the laws of armed conflict, somebody has to be responsible for making a decision to take a lethal action. You cannot have you cannot have a robot shoot a child holding a toy gun and say, well, we don't know why it did it. Oops. You can't. Somebody somewhere in some chain of command will have been given the responsibility to take the risk for allowing that to happen, and will be responsible for the consequences of it happening. And that's why I think, these conversations are really great in helping frame for people who might be put into that situation as future commanders in the military, and for other people to understand outside the military that we're not on the verge of ever doing this. There are, our adversaries may do it, and it would be very important to know how to respond if our adversaries do it. But at the moment, that ability to explain how an AI, especially a neural network, comes to a conclusion is so fuzzy that no military commander would take the risk when he could send somebody in who is highly trained and has much more general intelligence and can assess the situation properly, or just and we find this in cyber. You could decide to mount a cyber attack, or you could drop a bomb. It's much more intuitive, and it's much more comfortable for the commander to use the tools that they're used to and aware of. So not only will there be a legal barrier to the use of these sort of technologies, but there will be a mental barrier from the commanders who will not feel comfortable taking the risk, especially because they don't know what the consequences for them are.
Well, I'm going to push you on that, Matthew, because I mean, humbly speaking, I mean, I actually disagree with you on that a little bit. And let me just kind of throw this out, in terms of as a conversation. One, when you have the chain of decision making farther and farther away, that sense of culpability, right, sort of diminishes. You know what I'm saying? I mean, so I think that's also the worry. The worry is that, there's so many ways of sort of at the end of the day, even blaming, right, the AI for mishaps, that becomes more in the court of whether it's public opinion or in an actual, military court, becomes then an out for those commanders. So that's something that, again, and I don't feel like you have to respond to that, but it's something that intuitively I have to say, questioning. The second thing I would say is, for Western militaries in particular, but not just Western militaries, look, we have a recruitment problem. There is just not enough people who want to join the military. Like, I mean, I've written a book on the military. This is a big issue. And so you can see where the West is going because of demography, right? I mean, it's a declining population overall. And second, as democracies, as liberal democracies, where at the end of the day, people who take you to war have to end up paying the political price, those two things mean that, frankly, I disagree with you on that, that commanders over time are going to have to basically start relying on the technology because of the challenge of getting the foot soldiers.
I don't disagree with that. I'm just saying in the short term, we're not launching anything, and it will require, just as it does in cyberspace, it requires comfort on and knowledge on part of the senior leadership, the current senior leadership of many of the armed forces in the world. Grew up in a time before the internet being widespread, and so cyber is not an intuitive place for them.
Yeah.
There's or even the next generation down. So eventually, these things will get worked out. But if we don't have these conversations now, if we don't look at the drawbacks, then people may just buy the hype and say, well, this is a solution to my problem, let's field it. And then, then you work out all this problem afterwards in inquiries, and we don't ever want to get to that.
Yeah, no, a fair point, absolutely. Okay, Robert, big question for you is, what are the controversies? I mean, obviously you've heard already, and I guess the audiences have heard already a number of really important controversies already, but could you lay them out for us? I mean, as much as you can, in terms of what are the big debates out there?
Sure. And this ties in very closely to what you and Matthew were just talking about. And I'm not sure where exactly I agree with. So I'll just kind of spin this out, and we'll see. I think it's sort of an answer to the question, to your pushback about to Matthew as well. I think that the most dramatic and talked about applications of machine learning and AI in the defense sphere comes for the potential for autonomous weapon systems. So we've already been talking about that can execute a complete engagement cycle without human input. And in some important ways, these have been around for decades already. I know the US military fields both its Aegis and its Patriot missile systems that are effectively, in many ways, autonomous. But these are strictly defensive weapons that operate within very narrow protective envelopes. But the technology is now matured to the point where it's possible for autonomous target discrimination and selection to be done in an offensive capacity with some accuracy. And the major advantages of this are speed of reaction and the ability to get into places without putting any human beings at risk. So it's a continuation of the idea of drones, but with also that snap reaction time of being able to react at machine speed rather than being able to react at human speed. And that's where the main advantage in kinetic or munitions warfare is seen to be. There will definitely be legal barriers and mental barriers for formal institutional adoption for these things. I think one of the major problems and controversies that we're going to face is that the technology is now becoming so widespread, and that there is such a low barrier to entry for this particular field, that we will be facing organizations and individuals in the next decade who do not face this barrier. Who are happy to embrace an 80% solution or a 50% solution, whereas our military culture, our defense culture is such that we don't want to take that risk. We need a 100% solution. We want to be sure that these things are going to not cause collateral damage, that ice cream cone in the child's hand is not going to be mistaken for a gun. When you, like, right now, this technology exists that you can automate that process. And if you don't care that much if the child is carrying a ice cream cone or a toy gun, yeah, that level of autonomous behaviors is already achievable. It is not at the point where it is something that can be responsibly placed into weapon systems or responsibly developed in any kind of operational way, but it can definitely be irresponsibly done. And I think that's going to be one of the major problems and one of the major distinctions. Less talked about, but also controversial, are the many potential non-kinetic applications for AI systems for defense as well. The idea of the signature strike, for example, wherein a target for an attack is selected not because of who they are, but because of where they fall on some kind of disposition matrix of behaviors or locations and established personal relationships. That's all vacuumed up from big data, run through the algorithms, and targets for military targets are potentially chosen on that basis, on the basis of these pattern of life analysis, rather than the identification of specific targets. And those processes are accelerated by AI systems that self-adjust and learn what hostile patterns of life look like in assessing vast data sets. The mass persistent surveillance technologies that provide these data sets, like the wide area motion imagery, the WAMI, which use airborne cameras to simultaneously track a whole city-sized area, are increasingly ubiquitous. And computer vision algorithms can and will weaponize these tools without any difficulty. I think that's probably where we're far more likely to see the application of artificial intelligence and machine learning tools in the near term, is in sorting through vast quantities of data that have been assembled from like these WAMI programs that are essentially keeping entire areas, possibly entire countries eventually, under continual surveillance. surveillance. And so you can track one person moving through a city over this course. You can track them uninterrupted moving through a city. Now that these technologies are becoming better known, there will certainly be countermeasures for them that are arising, and people will start to find ways to kind of bypass that and get around that. Like, it's inevitable. It's one of that. It's that cat and mouse game of the militarization of technology. It doesn't give everyone a god's eye view of the world, but it is a really important thing. It's something that AI can do quite well, that you are in fact probably going to need machine learning algorithms to really take full advantage of. Similarly, I know that one of the popular books out there on the weaponization of social media is Pete Singer and Emerson Brookings' Like War, which examines in some ways the intersection of AI with cyber warfare and social media, mass psychological operations. And its argument can be summed up by a quote that it uses from social media technologist Aviv Ovadia. And he describes weaponized artificial intelligence as, quote, "We are so screwed, it's beyond what most of us can imagine. And depending on how far you look into the future, it just gets worse," end quote. And the use of AI to automate tasks involved in surveillance and persuasion and deception, manipulating videos and creating deepfakes may well expand the threats associated with privacy invasion, social manipulation. Various data analysis tools that exploit AI systems are increasingly efficient at turning bulk data collection of digital activity into meaningful signals intelligence for law enforcement and military use. But I won't go on for too long, but to touch on some of the other controversies, the idea of bias is deeply embedded into that. Because it was computer scientist Melvin Conway who formulated an idea in the 1960s that thereafter became Conway's law, that computer systems reflect the values of those who designed them. So computer algorithms, particularly data-driven ones, are inherently brittle. They cannot generalize. They can only consider the quantifiable variables that are identified early in the design stages when they are being coded. And a growing body of scholarship demonstrates that these variables are in no way objective. And I believe, Bessma, you talked about this a little bit earlier. These reflect, in the spirit of Conway's law, the values of those who program them, intentionally or unintentionally. And which leads us to the idea that all data is dirty. It needs to be, there's always noise, there's mess, incompleteness. So machine learning systems necessarily have to make things up, they have to cut corners, they have to make assumptions for smooth operation. These are not objective processes. These processes are always determined by people. And any AI that learns from human-derived data will learn human biases whether we want it to or not. And if these systems are used uncritically in governance or for access to services or in a military or defense context, then we're going to be replicating and aggravating any of the racist, the sexist, any of the other undesirable policies that are essentially coded into them to begin with. So neural networks are only as good as their inputs and only as moral as their users. There's a lot of other controversies that I could go on about. I think that's we can get back to them though. I'll leave off there.
No, that's great, Robert. And we're getting a lot of great questions, so please keep them coming. We are going to turn to them in a few more minutes. And if I may just kind of, as the political scientist me, I have to point out, you've raised some really great issues and kind of the state of play too, for example, in this hybrid war gray area that the military is calling it, which is this idea of disinformation, right? And I mean, obviously AI is not, always a part of this, but it can be. It is about sowing chaos, right? So about really fomenting internal disorder, and we've seen that being used. Recent reports by the Canadian government's cybersecurity center or cyber center, talked about the Chinese and the Russians and even the Iranians really trying to undermine perceptions of legitimacy in our democratic process, right? And that, what does that do? That's a sort of a new. And here's the thing that I find really interesting is that all of these technical applications are far cheaper than, for example, sending, a KGB, the new FSB, for example, officer to the West. I mean, that's the point of it. The point of it, this is a cheap application of undermining other countries. And so this is the danger of it. It's also the high sense of deniable plausibility, right? You can more and more say, well, that wasn't us. Those were patriots in the basement. I mean, that's not our fault. So there's so much there that, again, just giving you the audience a sneak peek on the things that we're going to be talking about for the next 6-7 months. So moving on, I want to ask you, Maura. I mean, you've heard both Matthew and Robert give us a lot to chew on. And you coming from the technical space, I'd love for you to just kind of reflect on anything that you've heard, raised today by your co-panelists that you think really merit conversation.
A couple of things. One is we tend to talk about this as the total replacement of humans, sort of the Terminator picture that comes in our mind. But the augmentation of humans is a different aspect. AI can process information much faster and in many ways more accurately. And those aspects may not, or are likely not, as dangerous as some of the other pictures. The other thing we focus on, and we did it even today, is we focus on the offensive use rather than the defensive use. I have no problem using an AI to go out and get rid of a landmine. I'd much rather blow off the leg of a robot than a real person. And I think those two uses raise very different considerations, and I think we have to distinguish them. Probably one of the things that concerns me most is the use of these tools on marginalized populations that don't have any input, consent. And I guess the last issue I'll raise is adversarial AI, where with deep learning, if you put a piece of masking tape on a stop sign, all of a sudden the autonomous vehicle thinks it's a speed limit or something else. And I worry a little bit about what we're going to do about the adversarial impacts of how these tools can turn around and start attacking the people who are using them rather than the enemy.
Yeah, absolutely. You've raised that offense, defense is such a, I mean, that is so valuable, that really helpful for us to think about it. And I guess also the concern is that sometimes, as you said, sort of there may be kind of a social and political acceptability on the defense side, but the fear is, I think, by civil libertarians, obviously, is that starts to creep into offense, right? So, this is obviously a mission creep fear that some might have, but certainly I think the distinction is really important. So thank you very much. Matthew and Robert, is there anything that you've heard that you'd like to just kind of pick up on and address before we turn to the audience for their questions?
I have something, if Robert doesn't mind me going first. So one of the things that I wanted to talk about, and I don't think we've touched on it, I think we've talked about the limitations, but it's the exactly in what way narrow AI, weak AI is brittle. We talked about it being brittle. When you train a neural network, and you can see this when you use Google Translate, or you try to use a voice assistant, or even better, try to do speech to text somebody, because it's usually such a small sound clip that good luck getting the exact text that you were expecting. That they're, neural networks, those sort of approaches to AI, and they aren't the only one, they have a failure rate. They're 96% accurate. The other 4% of the time is they don't fail in ways that are intuitive to humans. If you ask a human to identify a tank, it sees something, it's like, no, I think it's a rock. And a human will pick something that is the size and shape of the thing that they're looking at, even if they don't recognize what it is. If you do that with an AI, they could respond back in that 4% of times when they should be able to, but do not give you the correct response. They'll respond back with anything out of their vocabulary. And if you're identifying tanks, and you see a friendly tank when it's actually an adversarial tank, well, maybe that puts you in danger. If you see an adversarial tank when it's a friendly tank, that's really, really bad. And so the people using these technologies, and I love the the offense versus defense. I think in defense, yeah, absolutely, go to town with it. But in the offensive side, you have to understand if, say, it's helping you make a decision, helping you, find all the tanks on a battlefield, that if it says there's a moose and you look, you physically look over and you say, that doesn't look like a moose, that you understand why it's telling you that. You don't spend, 5 minutes of precious time trying to figure out how to get the AI to work correctly. You realize that it's just given you the wrong response, and it wasn't the response you were expecting. So you have to sort of double check in these, and maybe that will get better in the future. But we're already, we've already increased the accuracy of these sort of things like classifying paintings and stuff so much in the last few years that it looks like we're back into incremental improvement. We're not going to get to 100% probably ever, but we're not going to get really close to 100% anytime soon, unless there's another breakthrough in the way that these approaches to AI work. Yeah, and that's all I want to say.
Thanks so much.
So I can pick up on that a little bit. And one of the last big breakthrough that really happened in AI was around time of 2006 or so in the development of these deep learning techniques. And the important thing to realize about that really set in motion all of the the AI boom that we're currently experiencing. The important thing to remember about deep learning and the backpropagation algorithm that it's based on is it was actually discovered first back in the 60s and rediscovered in the 70s, the algorithm that it was based upon, and finally published in Nature in like 1986, I believe. And then it took another 20 years or so before the application of that could really reach fruition, when processor speeds and memory and so forth and costs had dropped sufficiently to really allow that algorithm to be practically applied. And so when we're looking at artificial intelligence and we're looking at where we're at and where we need to go, there's the world, the sky's the limit in terms of finding new narrow applications for machine learning and finding ways that we can automate different processes and apply some autonomy to them. If we want another leap, if we want another really big step forward, it's not going to come with what we currently have. We're not going to get to a generalizable intelligence through incremental progress on where we currently are. It's I think, vanishingly unlikely. There's going to need to be fundamental breakthroughs in the field, and we can't control when those fundamental breakthroughs happen. The last one, the backpropagation breakthrough happened in the 80s, and we're only just seeing the benefit of it now. So this is one of the strategic considerations. If you want to frame AI in defense terms, you have to think about it as, where do we want to invest our money? A lot of the big tech companies are vacuuming up tech talent at an astonishing rate and paying large amounts of money for and putting them to work for applications of existing technology. And there's less research into fundamental questions and fundamental computer science research going on in the big tech companies than I think is perhaps realized. Whereas investing in things like university research departments and such, that's a really good strategic investment if you're looking for fundamental breakthroughs in artificial intelligence. So I just wanted to follow up Matthew's comment with that. And one of the other things that I'll also throw in there in terms of the unreliability, and this is also a follow-up comment, the amount of reliance that we want to place on AI systems. I think we should also keep in mind how reliable the software industry and software engineering is. There was an XKCD webcomic written by a NASA roboticist, Randall Munroe, who I believe his quote was, "Our entire field is bad at what we do, and if you rely on us, everybody will die." And in the software industry, it's an exaggeration, but there's typically a rate of between about 15 and 50 errors per 1,000 lines of programming code. These are of varying severity, but all represent flaws in the running of the software. And if you rigorously test and debug, this can go down to 0.1 to 0.5 errors per 1,000 lines of code. But when you take a look at something like the F-35 fighter jet, that contains 24 million lines of code. So even if you rigorously debug it, you've still got about 2,400 errors lurking within its software. And those are kind of those bugs, errors, failures are perhaps inescapable in modern software and much more likely to occur as the complexity of these systems increases, particularly if time and resources are not devoted to robust security certification and rigorous testing. So the more complex a system is, the more likely it will fail and fail in unpredictable ways that make it absolutely impossible to predict what the downstream consequences of the failure is going to be on sophisticated systems. And perhaps most importantly, the solutions to accident and error preventions are going to be organizational and bureaucratic rather than technological. So these are good conversations to be having now when the technology is really still in its infancy.
Thank you. That's fantastic. We're getting some really great questions, so we'll turn to that now. And I'm going to ask them two at a time and open the floor to anyone who wants to sort of jump in and answer them, but I think bucketing them might help. Okay, so our first question is, and I don't know what all this means, so hoping you guys can decode. What about IAI, Harpy, developed in Israel? Could the usage of loitering munitions that can search, detect, and attack all on its own without human intervention be more common in the future? Our other question is, AI algorithms are heavily depending on the data. How do you see Canada as a society? How do you see us facilitating the access to data to learn the intelligence? Anybody who wants to take either one of those?
I can talk a little bit about the loitering munitions, and I think that's absolutely a direction that that defense can go. I think that again, I tie that back to the use of those systems is going to be very tightly controlled, or should be very tightly controlled, because you're not going to need a lot of errors and you're not going to need a lot of civilian casualties and collateral damage before that entire system is scrapped by a responsible user. So this goes back to the idea of responsible and irresponsible uses. A system that can loiter and choose and attack targets autonomously without a human in the loop, without a human decision having to be made there. That you're placing an enormous amount of trust in that system, and if that trust is violated, that does not pass what we at CFC call the Globe and Mail test. Would you want that on the front page of the Globe and Mail anytime, perhaps bereft of context? So I think that devices like that, and Israel is is at the forefront of fielding technology like that. Certainly in a defensive capacity I think we're going to see quite a lot more of that. I think we're going to see quite a lot more of that used by actors that do not have the same level of accountability and responsibility, or do not feel the same level of responsibility to make sure that what they're using is going to be doing exactly what they say that it's going to be doing. So that's my perspective on that.
I can touch on data if you want.
Please.
So there is an inherent tension. These tools, the more data they have, the better the training, assuming good quality data that's been cleansed and so forth, doesn't have the bias we talked about. But the more data, the more intrusive of privacy also. So, there's that tension between how much invasion of privacy, how much surveillance are we willing to put up with, both in our own countries and in other countries, in order to get this data that's going to be necessary. One, you'll need the facial recognition if you're going to have these tools be able to, again, figure out what's a combatant child versus a non-combatant child and so forth, but also the land and the property and the domains, and to be able to have a drone navigate a city and a street. There's going to have to be massive surveillance, and I think that's a real challenge. Do we collect it and have better tools, or do we protect privacy and maybe have less accurate tools?
Yeah, thank you. Our next set of questions. Do you think AI needs to be regulated worldwide, similar to how we have done the same, and I'll correct the error, to nuclear weapons, which we haven't actually regulated, but that's a different story. And I know there are, of course, this is the thing, with rules of engagement, right, we can refer to things like the Geneva Convention, right? This is sort of an established UN, affiliated regulation on, what is legitimate, right? So we have rules of engagement out there that say you can't hit a school, you can't, hit innocent civilians, hospitals. Now, lots of regimes and governments have transgressed and not done that. So I'm going to, obviously say that caveat, but we have so-called rules. This is a space that is, let's say, unregulated. And I know there are these things like responsible use of AI, these Montreal conventions and all the others, but they're still very much voluntary, right? There's no actual kind of mandate on that. So anybody have any thoughts on governing the use of AI, particularly in the military space? Is there even talk about this in sort of the rules of engagement or the Geneva Convention?
I think there's a difference we have to flag between what's ideal and what's possible. Right. And I'm not sure it's possible because, as we've talked about, they're good actors and bad actors. There isn't even agreement around the world about whether the development and use of these tools should be permissible. You have different schools of thought and no agreement on that through the UN or anything else. There's some who feel, well, they're dual uses and we're not going to stop the development because there may be good uses that we get in the way of. Really, I just don't see it as feasible, even if it was, likely to happen or possible. I think nobody wants to be the one left out who's over-regulating while everybody else is, having a free-for-all. So I think that poses, practical challenges. Whether it's a good idea is a different story. Obviously, it's a great idea.
Mara, you've outlined the distinction that we use in political science, and you're the lawyer, but I've always said lawyers tell you what's ideal and your political science tells you what's the reality. So I'm totally on with yours. I'm just surprised, the Osgood Hall, professor has a way of seeing it that way too. So thank you. I love that. Matthew or Robert, any thoughts?
So I'll go before Robert, just because I can give you the current military view. And I would relate this back to how we work in cyberspace. So there are no international norms for what's allowed in cyberspace. And that's really what we're talking about. I don't think we get to a test ban treaty like the nuclear test ban treaties or the non-proliferation treaties. I do see us getting to international norms eventually that say, it's not right for a nation state to do X or Y, and if they violate that norm, you can name and shame them, and you can, pass Security Council resolutions against them, and you can have sanctions, or you can maybe retaliate in the real world or in cyberspace and call it justified. I could see exactly the same thing coming about in AI. Hopefully it doesn't require a series of tragedies in order to actually get to that point where people feel that, you shouldn't have to step over the line a dozen times before people say there's a line there.
Right.
And so hopefully we get there. Hopefully conversations like that help us get there, at least in the Western world, and then set a standard for how we proliferate this technology and the knowledge about it and its safe usage.
I mean, we have this Talon manual, right? I mean, there is this sort of, principles, if you will. It's totally voluntary, of course. Is this a good starting point? Should we start with something like the Talon manual?
Actually, so, I know Mara's probably better qualified to comment on this than I. Talon Manual 1 was all about cyber warfare, which we're not entirely sure has ever happened. We're not entirely sure that anything has ever risen to the level of armed attack. Talon Manual 2 extended that to peacetime operations, and it muddied the waters. It muddied the waters from a perspective of working in the operations side and having to read these things. And I have no idea how the lawyers think about it, but Canada has not settled on a position adopting or rejecting the Italian manual at this point, to the best of my knowledge, and I'll let someone from JAG confirm that. But basically, it's unclear, and there's still no consensus. But it is an extremely useful thing to start the conversation with.
Robert, Maura, any thoughts?
In terms of regulation, I think that what exactly we're regulating has to be discussed there, because if AI and machine learning are these general purpose technologies, then regulating them is kind of like trying to regulate electricity, which does happen. But in terms of you kind of have to think of it on a different scale, on a much broader scale. What I think we're really talking about in terms of regulation is regulating the lethal autonomous weapon systems that are because that's the main concern, I think, for regulation is killer robots, and those. I mean, there's probably, I think that Matthew has the right of it, is that there are eventually going to be international norms that are adopted surrounding this. And I think we're probably going to get my prediction, historian, not a prognosticator, but where I see this going in the next 10 years is that we're probably going to get to a point where it is widely recognized that these lethal and especially offensive weapon systems cannot be responsibly developed with the technology that we have, barring some unforeseen breakthrough that really elevates us to the next plateau of what is possible with computer systems. I don't think that I don't see us bridging the gap between what is theoretically possible and what can actually be operationalized anytime soon. I think that gap is going to remain. But again, that's responsibly operationalized. There are plenty of ways to irresponsibly operationalize this, and I think that not just regulation, but the entire idea of counter autonomy as its own defensive field is also something that is going to be coming into its own in the next decade or so. The sets of capabilities, of tactics, techniques, procedures that can cause autonomous systems to fail in their intended mission. And Maura was talking about this, about the adversarial aspects of AI and the adversarial imaging to trip AI up. I think that is a field that is and counter autonomy is a field that is going to be important to look into, because I would imagine that we're going to see a lot more irresponsible uses of these technologies than we will the operationalization of responsible uses of them, and how to fight them, how to protect ourselves from them is something that's going to be really important.
Maura, please, would love your thoughts on this too.
I think I gave most of them, but what stops anybody today? I think in the United States, you can strap a gun and a drone and fly it around in many states. And what stops this? And that's a really scary question.
Absolutely. So we still have a lot of great questions. By the way, please keep writing them, because actually, even if we don't get them today, I will make sure that they are in our future webinars. So please keep them going. They're really just fantastic. Okay, our next questions are, there was some talk about distance between the user of the AI and the potential effects of AI. How does the notion of power to the edge or network-enabled operations, where AI would enable distributed decision-making and self-synchronization, affect the ethical concerns? Another question we have here is Phalanx is the only system I'm aware of that can open fire by itself. Maybe someone can comment on that. And the last question I'll just pose quickly. So what happens today when a soldier makes a mistake and kills a person? What would happen to an AI that makes a mistake? Is the commander responsible for the AI and human in the same way, or is the commander more responsible for the AI? Oh my God, I love these questions. Okay, to anybody and anyone who wants to answer any of those three, please.
I can touch on the third.
Awesome.
Right now, a commander is not responsible for the mistake of a commandee unless they've given the order or they've ratified it after the fact. I think and we talked a little bit about the liability or the accountability gap here. I don't think it is reasonable to hold a computer scientist who programmed a system who has no experience in war and cannot possibly predict every circumstance that the weapon is going to be used in. Then you go the next level up is the manufacturer. Well, usually manufacturers of well-known dangerous products, either there's what's called strict liability, is they're responsible for everything that happens with it, or they're not. And for guns and things like that, the risks are well known. So at least in the United States, there's a very powerful gun lobby. So they're not responsible. So then go up to the commander who, should you hold that person responsible? They're not a scientist. They're not controlling something that's autonomous. They're responsible to deploy it in a situation where it shouldn't be deployed. But I think there's a real vacuum in who's going to be held responsible, who it's fair hold responsible. So I'll leave it at that.
And I have to say, I mean, thanks, Maura. And I have to say, I mean, I think, from the University of Waterloo's perspective, I mean, there's just so many, I mean, really concerned students, right? I mean, and researchers who are also starting to really think about, as they hear more about, they kind of, let me just say, sort of the sketchy ethical, gray ethical issues and use of technology, just kind of like, wait, am I contributing to where this technology is going to go? I mean, these are real kinds of, ethical dilemmas that researchers are having at the moment, students are having. So really, I appreciate the sensitivity of the way you describe that. On the other questions, Robert, Matthew, any thoughts?
Yep, I have one. The power to the edge network-enabled operations question, that sounds like something straight out of a Canadian Forces College seminar. We're big on the idea of power to the edge. And which was kind of a way of thinking about this in terms of pushing power and responsibility down to the lowest level possible rather than centralizing it up higher in the hierarchy. And this is one of the principles of military operations in Canada, at least, okay, one of the ideals. It often doesn't, we often don't actually get there, and there's some complex interplay between technology and and the centralizing tendencies of technology and the actual ability to devolve responsibility and push that further to the edge. But to answer the question of how AI can affect some of these concepts, the way I conceive of it is that the real problem we need to think about is how AI is going to be implemented. And there's really a couple of possibilities here. There's sort of a hub approach or a battery approach. And if we think back to my electricity metaphor, it's about whether or not you've got everybody who's using this utility. Are you connecting it? Is there one big power plant that you're connecting to with power wires, or does everyone have a generator at their own house in order to do this? And the metaphor, I think, is for AI is, are you running the AI algorithms and the software on a central server somewhere that everybody has to connect to? Or do you actually have those algorithms running in your device, in your backpack? And there's a lot of ramifications for that decision. I know that the big tech companies really, really want us connecting to their servers. And if you use Amazon Web Services or any of those things, you can connect to their servers, and you can pay a fairly low cost, and you can use almost any AI system imaginable now. But that's the hub approach. Will that work in a contested battle space? I suggest probably not very well, particularly battle spaces of the future where you're not going to have necessarily permissive EM environments where there's going to be adversaries attempting to jam any of your devices. What you're really going to need is AI that is, if it's going to be useful, it's probably going to have to be self-contained within the devices that are with you at the time, rather than something you've got to connect back to. If you're constantly having to connect back over the air to use any of these systems, the military utility of that drops sharply. Not to say it's not there, but in terms of dispersing power to the edge for operations, you have to think really long and hard about how you're going to do that. The military today could probably get a contract with Amazon or any of the other big tech companies in order to implement more machine learning, database management and those things. We could definitely do that. That does expose us to an awful lot of risk in terms of third party, not just the liabilities, but what had a lot of the technical data for the F-35 was stolen because a third party's network security was breached, and that was removed. So there's a lot of questions concerning how best to get this technology out into the hands of the people who can use it. And I don't think it's necessarily compatible with the idea of power to the edge and with with this whole concept of network enabled operations. We have to think really hard about where the processes are taking place and how we are connecting to them, how secure that is going to be, and how expensive it's going to be in order to get the Department of National Defense to actually develop the kinds of dispersed instruments and tools that would be really useful in the field, but that don't require us to connect to some central, possibly third-party server in order to use. So that's something that I've been thinking about for a while. So I really like that question. Thank you for posing it.
No, fabulous. Thank you so much for the answer. Matthew, thoughts on the phalanx question?
I will just speculate because if it's what I think it is, it's a phalanx gun system, which is an anti-missile system on board a ship, and you only enable it when you're not in port, when you think you might be under fire. And I don't think anybody gets to go out on deck when this is happening. So like you're at battle stations and you have this thing turned on, and it'll fire at anything that comes within range. Not AI, well, I can't say that it isn't AI, but it's an automated system for missile defense. So whether it has AI on it to make it to help it or not, I don't know. But it's similar to the loitering munitions thing. If it's for defense, if you've defined an area that says anybody who enters this area, we've put signs all around it saying you'll be fired on, and you enter the area and you get fired on, you don't have to have a lot of target recognition for that. It's a defensive measure, but it's not. There are reasons that you would want to do that, and there are reasons that you'd want to have AI to make sure that you can distinguish your troops traveling across the zone as opposed to opposing forces, as opposed to refugees, for instance.
Thank you. And I'm going to throw some questions. Maybe this one might also be something that you'd want Matthew to address. So the next three questions I'm going to pose are: how about the use of AI as a tool for multi-domain operations for foot soldiers in terms of efficient threat elimination? Another question we have is, if or once US military starts to use automated killer robots, can the Canadian military choose not to follow suit? Or is the Canadian military policy in this matter unfortunately influenced by the US policy? That's a great question. I think there's a lot of, natural Canadian skepticism about, the Americans and I don't think maybe it's a mythology, but it's there. So what is our responsibility? And we talked about the F-35, which, are these kinds of conglomerates. And certainly I think in NATO is an alliance that kind of mandates, some interoperability as well. So yes, thoughts on that if anybody has it. Another question we have, and we'll leave off on this, is it appropriate for us to have a conversation about the legalities and practicalities of autonomous weapons based on the premise that this type of weapon is in any way acceptable, and the premise that the research work that we as an institution, I'm assuming that means the University of Waterloo, participate in belongs in this type of application? I think that goes to that wider thoughts on sort of the dilemmas that researchers and students are facing. So I know I've packed in a lot there. And again, for those who've asked questions, I promise you we're going to put them into other webinars. So this is a way to keep you tuned into the rest of it. So 3 big questions. Anybody want to take any one of them?
I'll start since I just finished talking, but about the use of AI in weapon systems for supporting multi-domain operations and foot soldiers, and I would say that multi-domain operations, so the idea of say supporting someone carrying out a land operation, so a platoon of dismounted soldiers moving through a battlefield and supporting them in cyber is already something that I think DRDC is looking at, and the idea of being able to get them information, but also protect the network that connects them, and also see what other sort of electronic emitters there are around them that clearly could be useful. Having a uncrewed aerial vehicle overhead flying around, and perhaps with AI in it that gives you classification, saying, I see an animal moving over in that bush and a human moving over in this bush, where they're not actually. So it says weapon systems, like you wouldn't have the UAV with a weapon system perhaps, but you might have a rifle with a weapon system, like a rifle with AI in it that will help you deal with get you longer range. There is actually an open source project, I think it was, called the Linux rifle, where you tag somebody with a laser and then it fires itself once you meet the like once it figures out the best trajectory and it hits within, it makes you a marksman, it makes you a sniper. Have we looked at that? I doubt it, because it's a lot of tech to bring onto a battlefield, and you want things that don't break. But yeah, but the fact that that sort of thing exists, I can see there's a lot of, as Robert said, this is a generalized technology that has a lot of applications, and once you get used to it, and if you can de-risk it, then it just becomes software that you use.
Absolutely.
Yeah.
Maura, quick thoughts on our two questions remaining, or on the last one there?
I'll take a bite at the last one. I think it behooves us to do the research as academics, and here's why. I'm not saying I'm in favor of the development and use of these tools, but if the answer to the research is that they are in fact safer in terms of saving soldiers' life, they are more accurate at distinguishing because of the fog of war and all of the other things that impact humans, that they are in fact better at distinguishing combatants from non-combatants, and therefore will decrease the casualties of civilians, then I think ethically and morally it behooves us to use things that are safer and better. So I don't think we should shy away from doing the research. I think the harder question is the development and use, but as with many technologies, it's a fine line between the dual use question, that there may be perfectly legitimate elder care uses that robots can be used for that are perfectly safe and fine. And if you shut off all development, I think it's how we take the technology and what we do with it. But I don't think we just stop research and stop development. But I can understand that may be a controversial question.
Yeah, thank you, Maura, for saying that. And I really do hope that this webinar series is really just kind of helping or adding to just again, that research and information and knowledge for people to just kind of make these kinds of choices that they may have before them. Final thoughts, Robert, just 2 minutes remaining. Any quick thoughts?
I think that policymakers need to remember that, and the public at large need to remember that AI systems are just processing devices following algorithms. They have no actual understanding of the world, the situation, each other, themselves. Malicious intent, programming errors, or simple ignorance can easily subvert them. So when we're thinking about them as tools, AI systems are tools that can help to capture human intent and make it faster and more efficient. If we do not fully appreciate the limitations and all of the work that to build and implement systems that can capture our intent properly, safely, and reliable, then it is someone else's intent that is being captured and implemented within the AI systems that we use. Back in the 1950s, one of the founders of the field of cybernetics and artificial intelligence wrote that the danger of intelligent machines was not that they would achieve autonomous control over humankind, but rather that such machines might be used by human beings to increase their control over the rest of humanity in highly mechanistic ways. And I think that there's some real risks. I think that the real risk there is not so much about autonomous weapon systems and killer robots. It's what these processes, which are often highly opaque, are being used to accomplish behind the scenes and without us being fully aware of what's going on. And there are some potential military aspects of that question, I think, that we've gone over today that are highly valuable. So no, this is a great session. Thank you very much.
No, thank you, Robert. Thank you so much, Robert, Matthew, Maura. You guys have really helped, I think, again, as a novice outside party, explain so much. And I know that the audience, at one point we had 125 people, so that's a success for us in this day and age when we're all webinar fatigued. Our next event is being scheduled at the moment. We're hoping for the beginning of June, and we will send you information about the next event, but please stay tuned. I do have to just give some quick thanks. The brain power behind a lot of what you heard today in terms of questions and formulating is from my postdoctoral fellow, Jean-François Bélanger. So thank you so much, and you'll have a chance to meet him as a host soon. We wouldn't be able to get anything done in our group if it wasn't for Kirsty Kearney, who is also the host of this great event and doing so much of the background work. Peter Van Beek, who is our director of the Artificial Intelligence Institute. Thank you, Peter. I hope you're on. You better be. Who is leaving as one of the co-directors, but has been instrumental in getting this entire project off the ground. So thank you, Peter. Lastly, this video will be posted online. We will share it with you. It'll be on the AI website as well as the YouTube channel. So if you feel like going back and there are some great questions or thoughts that have been said, it's all documented. Lastly, again, those questions that you've posed, they're not going away. We got 35 questions, so a lot, and I just quickly scanned them. They're super rich. We will hold on to them, and we're going to try and feed them into the next webinars. So without further ado, thank you so much for attending, and we look forward to seeing you next time. Bye, everybody.